Start recording. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. In the pre-stream, I actually wanted to kind of carry something forward someone was asking about, and it's kind of a good just thing to show, so I think I'm going to show it. I'll just remind everyone, we're day 202 today. I'm going to jump right into it. So if you want to follow along at home with the source code and you pre-ordered the game, unpack day 201 source code and trajectory, and you'll be right where I am right now. But what I wanted to talk about just real briefly before we get back to what we were doing is if you take a look here at Visual Studio when we build our game, if we right click on something, you'll notice that there's these go to definition, go to declaration things, and they're always grayed out. So we don't actually have the benefit of using those features at all, in this project, right? But normally, if you build a project and it has what's called browse info, you can actually use those. And so what you can do, as I have another project here that we can look at, right? If you're just using the standard, if you just used Visual Studio to create a project using their project wizard and that stuff, it'll automatically be set up for browse info and all that stuff. So if you're in a project that normally has all that stuff, you can go ahead and right click on something and you can see that those go to definition, go to declaration things are there because the browse info has been built and it can load it. And so what that allows you to do, and it's not, I don't find it particularly useful in my code, but I do find it useful in the Windows source code. So for example, you want to know something, you're in this load accelerators or whatever, you're programming with that and you're where is that? You can right click on it and go to definition, and it'll come back and say oh, that was a pound define in the Windows headers that was mapped to load accelerators W. Oh, where's that? Go to definition. Of course, it happens to be right above it, but you can imagine it was somewhere else. And there's the actual function that's getting called, right? And that's just a handy way if you're trying to explore around someone's code base, you just have no idea what's going on. It's kind of nice because Windows headers are just this huge, nasty mess. And so being able to just kind of have the compiler automatically output the data so that you can just browse right to the right place is kind of nice. Now you can turn that on yourself. I just don't know if Visual Studio will load it without a project file, but you can turn that on yourself. In fact, let me see if I can find it here. So in the compiler, I guess there's a switch for it. I don't usually do it. So I don't really remember, but let's see. Browse info, anyone? Anyone for browse info? Browse info. Can you build the browse info? I don't know. Let's see. Browse info, browse info, browse info. Visual Studio command line switch, build, browse info. Pretty clear, right? Let's see. To create browse information for simple browsing, compiler creates an SBR file. I know, but how do I do that? Okay, FR or FR. Which one of these is the one that we actually want here, right? I don't actually know. FR creates an SBR without information on local variables. FR creates SBR with complete symbolic information. So /FR is the full Monty, right? That's everything. So /FR and then the path name. So if we wanted to, right, we could try that and just see if we can get it. And I won't spend much time on it because, like I said, I don't really care. But I just wanted to point out the fact, for people who might be interested in this, it's something that's probably worth knowing can happen. So yeah, if we just put a -FR just in our general flags, is that going to be sufficient? Probably. If I just do this, right? Let's find out. So yeah, I see them. There they are. SBR, SBR, right? So that looks like it did a reasonable job of outputting that. And so I think all we would then have to do is build that into browse info, which it says we need to do to run bsc make to create the BSC file, which is used to display the browse information, right? So again, I don't actually know how we would actually click the browser, modify the browser information file, or enable. So okay, so we can probably just point it to it directly. All right. So what we need to do is we need to call bsc make, And it looks like, I guess we would just pass all those files in. So something like, in the build directory called bsc make, star.sbr. I'm hoping it can handle star. I don't actually know if it can. But we do like star.sbr and see what it makes. Let's take a look. So did we get one of these guys? Did we get anything here? I don't actually know if we did. No. Doesn't look good to me. I'm not seeing much in the way of stuff here, people. And why did all our SBR files turn to zeros? Oh, there it is. So it just deleted them all. So there it is, handmade.bsc. I guess I should have started at the top instead of the bottom. So handmade.bsc is now some browse info. So in theory, and again, like I said, I don't know if this actually will work because I don't really ever do it. But in theory, inside our properties for our Win32 Handmade, maybe there's a way to get browse information set up in here. I don't actually see it though. Legacy SQL, machine environment, debug, connection attached, argument, executable. I do not see it. Let's see if the solution has properties. Start a project, product dependencies, code analysis, debug source files, configuration. Yeah, so I don't actually see it in here. So again, maybe I'm missing it, but my suspicion, like I said at the beginning, is that in order to actually have it do the browse, I feel like you have to have an actual project here, right? And it can be like, I think, probably a dummy project or something. But I think you can't just have a bare executable. At least that's what it looks like. Because let's see what it says here in these docs. Property pages. Let's see. Click the C++ folder. Yeah. So like that's not going to exist, right? We don't build anything in here, so we don't have a C++ folder. Now we could, probably cheese out and add just some dummy thing in here to do it. But yeah, that's what you'd have to do. So yeah, so like I said, just something that's good to know if you find that you need it. I never use that, but I do keep actually literally just one thing exactly like this around at all times, which is a Win32 project that I load up just for looking stuff up in Windows. Like I will often do it just so I can do that and go right to the actual definition for that thing, right? Kind of weird, but that's just, that's just what I do. So that's good. And now I will go ahead back to what I was going to do, just regular stuff. So I'm going to take that out because, like I said, I don't need it, and I don't really want the compiler to be doing any extra stuff. I like to keep the compile times as fast as possible. So I'm going to delete the BSC and the SBR there and just go back to where we were before and let that just percolate. Okay. So where we were at yesterday is we left everything in a running state, but only because we turned off the debug code, right? The debug code is not actually there. It's just hanging out in a bunch of if-defs. So if I was to go in here and turn Handmade internal back on so that we are actually compiling all the code, you can see that I've just got a ton of errors to deal with, right? And we were right in the middle. In fact, I think I even left, excuse me. I think I even left, an XXXUR here, right? What we're in the middle of doing is just trying a few different approaches to how we want to structure our debug variable setup. And I feel like, again, I feel like people don't really like spending time on doing the debug code. They want to do other things, and that's fine. But that's not really my jam. Like, I like to make sure that if there's something that I feel like there's a productive thing that, to look at code-wise, I feel like it's important to look at it, right? And you have to remember that, in general, patience is definitely a virtue in programming. And, we're only on day, 202 here? So that's like an extraordinarily small number of hours. That's like literally like, 205 hours, something like that, I think we estimated, is the total number of hours of programming. 205 hours of programming is like almost no programming at all, right? 205 hours of programming is less than 10 weeks of programming. And so, I've often spent 10 weeks on a single problem. So no amount of fussing with these debug variables that we're going to do on this stream should even come close to tapping out any serious programmer's patience level with it. And that's really an important thing to understand. Like, it's very important that you have to be like I guess the way I'd say it is a crucial quality of a good programmer is that they are willing to spend time solving a problem. And, that often is going to take many, many hours, right? And so if you're not going to spend time solving a problem, the only reason for that is because you had something else that was more pressing and you had to make a hard decision, right? So like, if you are forced with some kind of deadline that you have to hit, then you are forced to make decisions about what to spend time on and what to not, right? But we are not in that scenario, right? Like, we do not have deadlines. This is an educational stream. And so it's very important to make sure that, you spend time on things, enough time on things to see how they should work and to go through enough iterations of how the code is structured to make sure that you ended up on a good one and not just on whichever one you happen to do first or something like that. So yeah, it's really hard to overemphasize that. Basically, nothing we do on Handmade Hero will ever be done to the point that would even be what I would consider a reasonable amount of time to spend on it, actually, just because we, are constrained to 1 hour a night and have a fairly limited schedule. So it's like, anything that seems like maybe it's taking too long in your opinion, that's probably a bad sign. Like, you really want to make sure that you have a very, very large amount of patience for restructuring code, experimenting with code, and seeing how it goes. Because if you don't, then you probably, honestly, this is probably not the kind of code for you, right? Like, you probably don't want to be doing low-level programming or something if that's something that you don't like to do. Like, you probably want to be in a sort of a different field or something. Because most of what you do when you low-level programming is working out things very much like this, right? So let's take a look at where we were at. I was sort of looking at this debug stuff, and I'm not exactly sure how I want it to be structured, but I know that I want it to be able to support a few very specific operations. And so what we were doing is we were kind of going through and doing a bit of a transform here. And, again, we kind of want to play around with this and see what sticks, like see what makes it easy to add debug variables and that sort of stuff. So I'd like to go ahead and finish this transformation of the code, kind of get it working, and then I'd like to do some usage case stuff so that we can see like exactly how we might want to use this in a few scenarios in the actual code. Because again, we haven't really spent much time defining what we might do with the debug variables. We did some simple test cases, which is we basically took the debug stuff that we already had in the code and made sure we could change all of that to debuggers, but they were very simplistic, right? Like they were just things that were like Boolean toggles, because that's really all we had for debugging stuff so far. So what I'd like to do is then, once I kind of get one of this one version working here, I'd like to go back to the actual code, maybe make something like an entity viewer or something like this, like maybe make a debug thing that we can use to view something non-trivial. That plus the profile view, I think would give us enough of a core like sort of example that we would know that our debug system was good enough at that point, right? If those things felt like they were being handled in a reasonable way. That's my feeling on it. So let's go ahead and move forwards. Let's see here. Let's go ahead and move forwards on that. I'm just going to go ahead and let the compile errors drive this situation again. So again, one of the things that I don't love so far here is this sort of like var. I just haven't decided what the best way to store these things are, and I wanted them to be very flexible. I wasn't sure about this with the debug variable array thing, and I'm still not really sure about it, right? I just don't know what the best thing to do there is. And it could be something like this. It could be, and maybe this is something we should do because all of our stuff is like sort of push-based. For now, maybe we'll just use something like a debug variable link like this. And we could do something like, next. So this is a W linked list as well in here, like that. And then the debug variable arrays would just be sort of a sentinel-based thing, right? Like this sort of thing. So this would be like, a var group or whatever, that sort of stuff. And that just might be a little bit better than sort of the thing I was doing before, because again, this is all kind of like pointers, rat's nest kind of stuff anyway that we're sort of doing, where you can add and remove things at any time and other stuff like that. And so that might just be the easiest way to make sure that everything stays pretty reasonable in there. So I'll just gonna leave it like that for now. Okay, so we've got pretty much everything we want defined here. So I'm just gonna go ahead and make sure all that's implemented. Let's see, so if we are doing it the same way we were doing it before, when we do debug add variable, it just makes the variable. When we do debug add variable with a context, what we want to do is say, okay, we add the variable using this, debug add variable, but then what we do is we also want to add, if there is, a group active, we just want to add it to the group. That was kind of our definition of how this thing works, right? And I think we probably also want to, I'm feeling like we probably want this to be one more layer deep as well. So we probably actually want it to look like this, where we have debug add variable, and it's got the debug variable like group associated with it there, although even that, I guess, since we had a thing before it, we could just have debug add variable to group, and then it calls that one. That seems fair as well. So that would just be debug add variable to group, and that's just like, okay, we've got the debug state, we've got the debug variable to add, and we've got the debug variable group. And that would just be the thing that puts it on there, right? So we've got debug variable link. We're going to get one of those. And then we're just going to go ahead and say that the link prev, link next, same old stuff, exactly the same way. And in fact, this sort of thing you can even macroize if you want to go one step further. Like I said before, you can templatize it if you want to. You can even make a macro of it if you really want to. Like, for example, you can see in here, we've got sort of the prev next thing happening. Oops, I wanted handmade debug. Linked lists are so trivial, you can basically just say, all right, when you add something to it, this is exactly what happens, right? We always know that that's what's going to happen. So you could imagine saying, oh, we just want a macro for the way that you do a linked list or something like that, so we don't have to type it every time. It's just going to look like that. That's what it's going to look like. So if you always have next and prev, you can do something where you just say like, oh, all right, whatever the sentinel is, like this, right? Whatever the element is. You know what I'm saying? And then this code is literally just always going to be exactly the same. There's not going to be any particularly nuanced difference at all to it, right? And so you can pretty much just treat it like a rote thing. Something like that. And so you can do a thing where you're like, doubly dlist insert or something like this, and you can just say the sentinel and the element like that, and then this would do it. You know what I'm saying? So again, pretty straightforward. But if you want to just save a little bit of thinking, you can always just do that. You can say like, okay, I want to insert. There's the link that I'm trying to insert. Here's the group. And I know that thing has that sort of var group thing in it. Off you go. You know what I'm saying? And so again, that is also something that we could use in place of the of the other guy, this one right here. So you can take a look at, since we know exactly what this is doing. If we wanted to call it dlist insert, you could say like, oh, well, the sentinel is this thing, right? There's the sentinel, and the element is this thing. So there you go, dlist insert, inserted, right? Done. So again, if you hate templates and they always ruin your life or anything like that, and you don't have metaprogramming either, and you're in one of those situations where you're like, but I don't want to type a doubly linked list every time, you do have a third option, and that's just one macro, and it'll just do it for you. So that's always good. if you're in the mood, again, just giving you tricks, just giving you some things in case you hadn't thought of them already or used them already. That's one way to do it. All right, so there's our add variable to group. It adds it to the group. That's going to be an address because that's actually the thing. So then we've got debug add variable. In this case, it's just going to call the debug add variable to group thing in addition to adding the variable, right? So it's just going to be like context group, and then it's going to be var, like so on. And we'll only do that, assuming that there actually was a group for us to do it, and then it's done. Yeah. Yeah. We then have begin variable group, which again is just going to add a variable that's of the type of that group type. What did we call it? Var group. Short-term memory. Yeah, var group. And I don't know what we called this one. Did we call this one var group as well? Yeah, var group. Oops. There we go. Not too much to say about that other than it is just exactly what it needs to be. So then we can do begin variable group. That's going to add the variable. That's going to initialize the group itself. So we've got this var group. And again, you could do this way if you wanted to, because again, this is exactly rote and will always be the same for pretty much any linked list, doubly linked list that you have, right? The initialization for the sentinel is going to be exactly the same. It's just going to be that, ooh, that's, don't want that. There we go. That's just going to be the sentinel. Its next pointer has to equal the sentinel itself. And similarly, that previous guy has to equal the sentinel itself as well, right? And we could put remove in here as well. We just haven't gotten there yet, but we could put remove in there as well. And so there you go. That's the linked list. That's all good. And so if we initialize the linked list, when we begin the variable group, the only other thing we have to do after that is make sure we set that as the active group, right? So that now we know. And I guess, like, one of the kind of things that's a little bit annoying is we don't really have, at this point, we don't really have a lot of visibility into whether we will still want the whole, like, parent notion thing happening here, right? So we have, like, debug views, which would store the information that we need to store, and then we have debug variables, which would have the tree sort of stuff baked in them as well. And the question here is, do we still want to store parent pointers for variables? And the answer, of course, here is that, well, groups are things we make, but they, groups are things we make, but inside a group, we could be pointing to any given variable, right? And getting back to the previous one is largely, because that variable may be cloned in many views, getting back to the previous one is not a given. So I think we want to mostly do stacks here when we're doing traversal, because, or if you don't want to do stacks, then you can do a recursive function and let the compiler stack do it for you, well, the program stack. But in this case, I feel like we kind of want to do something where we're going to do, that kind of push and pop sort of a thing. So when we do when we do the debug begin variable group thing, we now have a problem, which is that when we do end variable group, we will not be able to do this operation, right? But that's a really simple thing for us to fix, because again, we can just leverage the compiler stack here. All we really need in this case, right, if you think it through, is we just need, when you end a variable group, to give back something that says what the parent was. So if we bundle those together, right, this is just sort of like a, variable group builder or something. If you give back something that has the group itself, but also its parent group, right, when it's being built, then we get around that problem. Because now we say, oh, debug variable group builder, right, that result, we're going to store whatever the context group was, and I guess I'll have to do that obviously first. And then we can just say, well, and then the group is captured that way. You know what I'm saying? So now, when we do begin variable group, like these guys do here, we just have to actually have, it's a little bit more onerous, right? It's this kind of thing. So that's one way you can do it, right? And it's really 6 of one, half dozen of the other. It depends in this circumstance, like what you're trying to optimize for, which one you would want to do. In this particular case, since I was just trying to show how that works, I can show you also the other way to do it, which might be useful, and that's to have some kind of a stack, right? So you'd just have a group depth here, and you'd have like a group stack, and the group stack would just be like however many deep you might ever go. There's no way you're ever going to go 64 deep when you're constructing these things. So, whatever. Doesn't really matter there. Anything you want. But point being, you've got the group stack here. And then what would happen is all this time, when you're doing these operations, you would look at whatever the group depth is. You'd look into the group stack for that, right? So I basically say something like, normally, we say context group. Instead, now we'd say if the context group depth is greater than 0, meaning there is something on that stack, right? And you can actually even get rid of that by pushing a synthetic 0 on. I'll show you that too. Why not, right? That would look like this. You just be debug variable, parent or something, and you do context group stack, context group depth, like this. So you do something like this, and when you have that group depth, we'd just take whatever the previous one was, right? So the group depth, well, I guess now, you know what? You just take which one it is. So if the group depth is 0, we take the 0th entry. If it's 1, so and so on, so forth and so on, right? Then we would just do exactly what we were doing before. We'd just say, add it to the parent, like that. I guess we should pass the state there as well. And that's all you have to do. And that gets rid of this stuff if you want. So again, if you don't like that and you wanted to make it, again, simpler, you can totally do it that way instead. And it's no big deal. OK. So then we, inside something like begin variable group, what we have to do there is say, OK, we're going to add a variable. That's going to give us back the variable that we wanted. And now we want that to be the new, foremost group, right? That's the one we actually want. Everyone else to be added in from now on. And so what we do there is we'd say, OK, whatever the group depth is, well, first of all, assert that the group depth, right, is less than the max size. Right, so we make sure we don't overflow. But then what we do is we say, all right, the group depth is going to go up by 1. And then we're going to write into whatever that group area is. Us. We are now the people on the top of the stack, right? Now, there's a little bit of a nastiness here, which is that we can't, because we're actually writing into whatever the next location actually is, this check is a little bit under, right? It's off by 1. Because it's checking to see whether group depth is less than array count, but when we increment it here, it might then be equal to array count, which is 1 past the end of the array. So what we want to do here is we want to back up by 1, right? And say, OK, we have to make sure that's where we were. Now, again, that's just debug code. It's never going to hit there. But again, I always like to have a thing that just lets me know in case I forget and use this code somewhere else. And it's like, oops, my bad, right? I don't want that to happen. I want to be notified. So anyway, the rest of this stuff can pretty much just work the way it was. We don't really have anything else we would need to do to these guys. But when we get to the end variable group, what this needs to do is, first of all, it wants to assert that the group depth is greater than 0, right? Oops. Because if the group depth wasn't greater than 0, that means we weren't inside a begin group, so that would be a bug. But then once we know that we are, we just back the group depth up by 1, and we're done, right? So that's all we need to do. But when we initialize that context now, we do need to make sure, when we use that debug variable definition context, this one, we do need to initialize that stack, right? So instead of this thing happening here, what we actually need to do is initialize it with no group, and then we would probably do this. right? At least I think that's, I don't, in fact, that's kind of odd. I wasn't expecting that to be what I would see there, but okay. So we have group depth equal to 0, and I guess we technically don't need to do that because that's there. But we would have the group stack first thing equal to the null pointer, right? So the base of the stack is nothing. So you can always reference it, and you'll find that. Then we would begin that variable group of the root, and we would keep going from there. Again, like I said, I don't really know why we had that root one in there. Can't say I get it. I'm sure we had a reason for it. So yeah. And the other thing I might do, just so we can debug a little bit of that, is say that, well, after we add all these things and we do end variable group at the end, I'm going to assert that the context group stack depth, right, or group depth is equal to 0. So we didn't leave a group open because I kind of feel like maybe we did based on what I just saw there. And there's nothing wrong with doing that in our code. It would still work, but I just feel like that's sloppy and I don't really want that to happen, so I'm going to go ahead and prevent it. All right, so moving along, let's see where we're at now. So use debug camref. I don't even know what that's doing anymore. Debug camref. I don't think it's doing anything, so let's get rid of that, like so. And let's see here, we've got debug variable tree, add tree. Okay, so now we're into the debug code side of things. So I think our variable stuff is now relatively correct for the most part, and it's sort of doing its little thing that it does, and that's all fine. Right. And there's some cool things that we can start doing now as well that I have thought of as we were typing that in, but we'll get to that in a second. So, okay, let's go ahead and clean this stuff up. If we're going to do an add tree, then we would need to actually just call this debug tree, because that's what those are called now. And so if we allocate one of those, that's all good, and we set the parameters, they are all basically the same, so there's not really that much that has to happen to that. That's basically the same as it was for the most part. So all we really need to know is we just need to know what the group is that we're going to be doing. That's a variable now, not this other special type, so that's all fine. So then we have var groups here, which I guess are just, you know, kind of putting in some placeholder stuff there, bitmap display and var group. This is debug variable to text, so it's basically just a way of making sure that we have shown that we know that these things, you know, are not necessary to convert to text, is mostly what I guess I would say about it. We don't really, there's some things I was thinking that we probably want to do here, but we'll talk about those a little bit later. Anyway, so that's all good. Let's see what else we got. So when we do write handmade config, now when we do our walking, this means our walking would need stacks, right? Because we no longer have parent pointers anymore. And like I said, this was a handy trick, but and it's good to know how to do a traversal of a tree, obviously, so I'm glad we did it. But because now a variable can exist in multiple trees at the same time, this no longer works. Because when the thing descends and then comes back up, it doesn't know which up to do, because there's many people who may have been its parent because it exists in multiple trees. So the only way to know is to remember how we got there, and that implies a stack, right? And again, just to sort of give you a very concrete idea of what I mean by that, so here's, right, day 202. Wah! You know, if I've got something that looks like this, and I'm trying to traverse it, you know, I go down here and I come back up using this link. I go down here, I come back up, and I come down here, right? The reason that works is because this tree, the reason that works with no stack, is because this tree has pointers going in both directions, or it did, right? It has the pointer down, but it has the pointer back up, right? And when you have a pointer back up, that means that you can always just climb up and do that traversal. You can always go, oh, I'm done down here, there's nothing left. I'll come back up, we'll come down again. Oh, I can come back up, because I can always ride that pointer back. But if those pointers go away, right, then you can't do that anymore. And so then you need to have a stack so that it's kind of like, when you're rappelling down the side of a cliff, you've got the rope there, right? So you can always return to higher places on that cliff, right? And the same thing is true here. It's like threading a rope through it. So as we descend down, right, we can always use the rope to kind of come back up. So what we want to do is any path when we're on an element, we want to have a stack that tells us what all the previous ones are. And that's exactly what we did when we built it, right? That's exactly what this is. And that's exactly what we're going to want to do. Excuse me. That's exactly what we're going to want to do for iteration, right? Okay. So assuming that we're going to have a way of iterating through these guys, I don't really remember. I know I had some reason, or I feel like I had some reason, that I've now long since forgotten, of why I didn't make an iterator for iterating over these guys. And I think it was because there were some like different things that happened depending on the expansion, like whether you went down them or not, and other things like this. And so, we didn't really make an iterator type thing for it. But at this point, I know I'm going to at least want the stack part to be kind of reusable in that sense. And so I feel like, at the very least, I will want something like this. So this would be like debug variable. I don't really know. Debug variable stack, something like that. And there's just the depth and the debug variable. Something like that. And so when I come through here and do this stuff, and again, like I said, if you want to, you can do this with a recursive function as well. In fact, if you want, I could show you that since you've seen me do the stack thing here. We could also do this with a recursive function. It's pretty straightforward, right? When you have something like handmade config, you just need to wrap these guys up. Like this stuff needs to be wrapped up in some state that you pass down, and then you just call a function every time you want to descend, right? So basically, the recursive function version of it just wraps these guys up. This like struct handmade config. And yeah, do I really have to do this? I don't know. I don't love recursive functions. You guys know what I would do here, right? You put this in here, you call handmade config, it just calls itself every time it wants to descend, and then when it's done, it returns, right, and pops back up. So I never like doing those, so I'm not going to do those. They stress me out sometimes. All right, so if you want to write the stack version, like I said, debug variable stack, we just have a thing here. It's got the count. It's got the stack. And really, I suppose, in some sense, you could even just write it in line first. I'm trying to think if I really would save that much from not doing it. But we've already got like the depth, So all we'd have is something like this, which is like what was the stack, right? Something like this. Okay. And that's 64 levels deep of a tree, which I really don't think we want to be getting into, so it's not something I probably have to think about too hard. So in here, you've got this stack situation. I could just initialize the depth to 0 or something like that. Initialize the first one to 0. Although I don't know if we really need to do that. Probably not. Probably all I really want to do is increment the stack depth by 1 and push on whoever the root of the tree is, right? So that's going to be the root group, and that root group, I guess, is just a regular thing now. So that's just going to be probably the root group itself, if you think about it, is probably the thing that we would actually just push on there, because that's the variable that we want to actually process, right? I think. I mean, that seems right to me anyway. So yeah, so we would start, we would start with the root group. Once we've got the root group on there, excuse me, we would just start with a while loop while the depth is greater than 0. So like while there's something on the stack, we kind of do debug variable var equals whatever the stack is, like this. So we basically take one thing off the stack, and then we go ahead and use it, right? We do the should write thing, all that sort of stuff. We then go ahead and say, like, okay, if it was a group, this stuff we don't need to do anymore. That just goes away, right? And this stuff is just, okay, if this was a group that we were processing, then we would want to take whatever its children were and push them on, right? We also want to do a for I loop in some sense, right? We want to be able to do a walk of siblings as well. So we've got those debug variable links. So technically in here, while we're on the stack, this would really probably look like this. So this would be this is really like the var group that we're talking about here, and then the for loop is going to be over its links. So it'd be like whatever the link is. Right? So I've got the var group. Next. While it's not equal to the var group sentinel, we just ride that list along. Right? So we just keep going. And then for each one of these, we now have a debug variable, which we get out. And that's the one that we process. Now, here's the part that's a little tricky, right? Is if we want to, the natural order that the stack will give us these things is not a tree. It's like and maybe we don't, I don't know, it depends on how we want to do this, right? But the natural order of the stack is not going to be a tree. If it's a recursive function, then usually what happens is it actually does view them in sort of a depth first order. So what will happen is we start at a node, right? And that node has a subtree, right? It's got some people in it. So it's got doot, or whatever, right? So it's got a pointer to here. It's got a pointer to here. And these guys have pointers, right? There's actually a sentinel in here. So there's, it's really that sort of thing, more like. You might say it looks like this. You know what I'm saying? So as we're cruising along here, we go through these guys. The natural order for a stack is to process all of these guys. So it'll process A, B, C, whatever. And it'll push onto the stack any of these guys who were groups. So on the side, we've got our stack here, right? And it goes like A, oh, is he a stack? No, he's not. I mean, is he a group? No, he's not. B, is he a group? Oh, yeah, he is. Put him on the stack. C, is he a group? Oh, yeah, he is. Put him on the stack. Then go pop the stack and get the next guy. Which means that we process everyone at this level of the tree before we process anyone who'd be down here. So it processes the tree, right? It processes the tree in breadth first order. It does whole rows of the tree before it does anything on the lower level. Now, a recursive function would do the opposite way. It would do a depth first. Because the recursive function goes, oh, start iterating, is A a group? No. Okay, is B a group? If so, iterate B. And it calls the function right there, right? And that's because what's on the stack in the explicit stack version is just the data. But what's on the stack in the code version is code and data, right? It's got the instruction pointer because it's the whole program stack. So it pushes the whole traversal state onto the stack, essentially. You don't see it, but that's what's doing when you do a recursive function, right? It captures the whole state there, then does this iteration, pops back to finish this one, right? Does that make sense? So yeah, I mean, that's just that's one sort of kind of benefit to using the recursive function, is that if we want to keep it stack based, explicit stack based, where we rewrite the stack, then you have this kind of nasty thing where you have to do the walk in breadth first order, or you need to do something that makes it sort of less efficient, if you will. Like, we'd have to think about how we were going to actually traverse these guys in some way that makes it so they will automatically do, like, you know, next. We put them on the stack when we need to remember to, like, come back to them, and so that they'll go in the right order or whatever else, right? So having that, you know, thing in the stack is actually kind of nice. Yeah. So if we still wanted to do it with our own stack, and that was something I just didn't think about when I was doing it. I was like, I tend to rather do stacks when I can. But in this case, it's not just a question of visiting all the elements. We actually do care what order we visit them in. Recursive function kind of has the nice side effect there. Now, it's possible that we could just actually do the stack version by augmenting it, right? So if you imagine what that looks like, that would just be like debug variable iterator or something like this, right? And that would be, you know, there'd be a debug variable on here that's like whoever is the guy we need to store what we would be doing, you know, with this loop, right? So we would need to store the terminator condition, which is like, you know, whatever the sentinel is, which is like the stop, you know, whichever the sentinel is to stop at. I could just call it sentinel. We need to do like where we were, variable like, right, link that we were at. And now if I augment the stack, this is sort of like storing that instruction pointer. It's like storing the state of the code, right? At that point. Instruction pointer is the wrong way to say it. It's like storing the local variables of the function, right? Is the better way to say it. Because that is the piece of information that we actually needed. You know what I'm saying? So if we want to, we can say like, all right, so now what we've got is essentially a stack of these iterators instead. When we push something onto that stack, right, it would look like this. We'd say, okay, the link is going to be the root group's var group next. That's the first one we want to process, right? And the thing to stop at there is going to be the root group var group. So now we've got the full state that we needed. So now when we do this, we just say, oh, okay, go ahead and get me, you know, that variable iterator, whatever it is. I pull that off of the stack. I come in here and I say, all right, let's go through and see. We got to start iterating over, and I guess I'll just call that iterator, right? We say like the iterator link is where we're starting from. We want to make sure that it does not equal the sentinel, and then we just kind of chain through there, right? All of this stuff stays exactly the same. The only change now is if we get down to here and we see that it's a group and we want to descend, then we need to store where we were, right? So that when we pop back, we will get to it, right? So if you think about it, what that means is that this guy right here, this iterator, we almost want to like always keep using him. So instead of popping the stack like this, we actually just look at what's on the stack, right? And we actually keep whatever the guy was that's there, right? And we use him directly. So we'd say something like, okay, we want to make sure that the iterator link is not equal to the iterator sentinel. We want to advance the iterator link as we go, right? Like so. And then we do that, right? And so this is just saying like, okay, you know, we've got these iterators. We're advancing this iterator as far as it can go. When we get out of that advancement, then we just say like, all right, we're done. So now we can finally pop that guy off the stack, right? But we leave him on the stack as an iterator until he finishes iterating that row of the tree. Then what we do here is say like, oh, okay. And we're going to have to do this slightly a little bit differently because we need to be able to break out of this particular list in two different places. So really this won't exactly be able to go there, right? And you'll see why in a second. But so assuming that it's a group, that means we want to iterate that group right now, right? So we want to increase the depth. We want to advance the depth pointer, by 1. So in here we would say like, okay, we've got sort of a new iterator that we're going to push on here. That's going to be whatever the current one is. We're going to fill it out, just like we did before, right? And that's just going to be whatever this variable var group next and this variable's var group was, right? Whatever that is, we're going to push that guy on the stack. So then we just plus the depth. And then the problem, as you can see here, is now we're like, well, okay, if we're iterating over that thing, we would want to now restart this iteration. Right? And so you naturally think like, okay, we break out of here, but then it's like, oh, okay, I've got this. Now I'm going to decrement my depth. It's like, everything's messed up. Well, the nice part is, since we're still in here, since we're still in this loop, what we can do instead is just say like, oh, well, what we could do is just say whichever one where this pointer is sort of pointing someplace in the stack, we could just move to the next one and use that next one and have it just start going from wherever it is, right? So what we could do is just say like, oh, just use iter itself, right? Set iter up to be the next one that we need, right? And so we've moved that one down the stack. And now off we go, right? We don't have to do anything else. This loop just keeps going. And then when we break out of here, we'll break one down and keep going with the iteration, with the stack popping iteration. Does that make sense? Hopefully that makes some sense. I think we might be able to unwind this one more, right? We might be able to do this with only a single loop because we probably don't actually need these guys. We just would need something that was like, if it hits the sentinel, pop up the depth. But anyway, hopefully you get the idea. So that's, like I said, that's if you want to do it manually instead of using a recursive function, et cetera, et cetera. But you want to control that iteration order. That's how you would do that. All right, so what was I about to do here? Convert debug variable link to debug variable star. That's a good point. These are supposed to be links. And debug variable type group. That's just called var group now. So that's fine. And what else we got? Debug draw menu, debug variable tree. So this guy, yeah, is just draw main menu. I think this guy is just going to be, another iteration style. So that's why I was saying like it'd be nice to kind of pull this out and have it so that you can iterate over it easily. Because you can see that we could presumably just wrap this guy up into an iterator that does just this part, right? And I just don't know whether, because there's kind of the part about every time you descend and stuff like that, the drawing code needs to know that you did that. So I'm not sure exactly how I want to abstract that out. That's kind of an interesting question, and I'm not sure. But since we're going to do this in two different places, at the very least, that does motivate me to maybe do that kind of that collapse to see if I can get it out to just be one loop there, which should be eminently doable, right? So if we were to enter, let's see here. If we were to enter this with this just set to being that initial guy, right? Then, or I guess we could say, when we pull this thing off the stack, we could simply check at that point. We could say, is it equal to the sentinel? If it is, we want to subtract 1 from the depth, right? If it is not, then what we would want to do is process it, which is what we're doing here. Yes. And then say, once we've processed it, move it to its next one. Does that make sense? So basically, while there is something on the stack, we will grab whatever that is. If it is something that we want, that if we're basically saying this iterator has reached the end of its iteration, then we will pop the stack. If it has not, we will get whatever the next one was and advance it 1. Oops, that's supposed to be a next. That would have been a fun infinite loop right there. We process the variable, whatever the variable is. And then we check to see whether we should push a new guy on, right? And that seems pretty straightforward to me. And we can sort of wrap this up pretty nicely, I feel like, if we want to, right? Just by sort of doing like a bit, just the barest, just a little touch, just a smidge, the barest smidge of wrapping. But maybe I'll save that for Monday. So all right, so if I come down here and let me go ahead and jump to the right place there. So there we are. And I am going to take this guy and use him as he is, right? So if we do this this bit here, again, this variable, excuse me, this variable tree stuff is just changing the name down to just a regular tree. Everything else, I think, is probably exactly the same. So in here, then, we're going to go ahead and do that traversal stuff. So that kind of comes out here like this. We then do, I guess, all of this stuff is all the same. That doesn't change at all. And then at the end, right, we do this iteration. There we go. Yeah, I think that's basically it. Now we, of course, have the problem of our lookup stuff we haven't implemented yet either. So we have to now start doing that. We want to, for any given variable, we want to do something where when we're displaying it, we, like I said, we have this concept of the debug view for it. So anytime we display a variable, we want to get its debug view, which will have this sort of stuff like what the dimension is and stuff, like we have this inline block and that sort of thing. So any given variable has to have that information. So we'll pretend temporarily that we have that, right? And in fact, I could do it this way, where we just go like, oh, we've got a view, and it's set to nothing. View cache. And I guess now I think about it too, I feel like we would have it so that when it gets the view for this guy, it's going to need to know what kind of view it actually has. And I do think that since the debug view, well, we might even want different debug view types for different things. So I feel like it might even be the kind of thing where we want to do it per one of these, where we say like, get debug view for, and we then pass that variable, right? In fact, I guess we could do it, for everybody and say, get the debug view for this variable, and it will get, whatever the appropriate debug view is for that variable. Then in here, we always use, whatever that thing actually was. Yeah, something like that. So yeah, I feel like that makes sense. There's some cool things we could probably even do. There's just so many possibilities in here. It's kind of crazy. Anyway, so when we do this stuff, I don't think there's really anything else in here that has to be modified. It's all pretty straightforward so far. And so really in here, again, that's just going to be changing this to be a view thing. This would be view inline block dimension, like so. Oops, but which one is it? .y? Yeah. Inline block dimension, and that's the .y. And let me just let the compile errors sort of tell us where to go from there. It's not a member of debug view inline block. Probably just dim, huh? Yeah. So I'll do a few more here and then we'll wrap up for the day. Bitmap scale, debug view inline block does not have an overloaded member operator arrow. You are correct. It doesn't. Bitmap display dim.size, so that's just again correcting this inline block. Dim x. What else we got? This is just again that same thing, view inline block dim. And let's see what we got. Bar group here. Should probably just make a dummy one of these. And this will crash us nicely. Kernel. There we go. Debug variable var. Not implemented. Wow. Okay. That is not how you spell variable. The variable would be displeased. All right, that'll crash anyway, so I don't really need a macro there for that, so that's fine. Debug variable reference undeclared. That is quite true. It quite certainly is. And I think I'll just comment this guy out for now because this is the guy who we're going to change primarily. This is the tearing off value stuff. So that's the guy that we're actually going to then, once all this stuff is working, go in and change to support kinds of more expressive drag and drop sorts of things. Re-implement with new system. So then let's see what else we got. Var group. This again is going to have to get that debug view. Debug view equals get debug view for this variable. And we're just going to go ahead and assume that we get one of those back. Whatever this guy actually is. There we go. Collapsible. That's what it is. So we would say that the view collapsible. Collapsible. There we go. Equals not view collapsible. That is also wrong. Expanded always for now. Okay. Almost done, actually. So I might as well just finish up the last of these before we call it a day. So this stuff, profile dimension, I'm not going to bother with those for now, so we'll just go ahead and get rid of that. We'll leave that doing its thing. What else we got? Assert context group depth. Does not have an overloaded member flag. You are correct. That is a dot. And group, context group. Is not a member of debug variable definition context. You are quite right about that as well. I agree wholeheartedly. But I feel like this should actually look like that. All right. And that's the end of that. All right. So that was pretty good. Again, we're working it into more shape. Like I said, this is something that takes a while because these sorts of things want to go through a few different iterations till you get them just so. And so I want to keep polishing that down. We got to kind of take a look again at the structure. There may be one more structural change that I want to make. We'll see. And that has to do with how we iterate over debug variables. And what I'm going to do is, again, like I said, Monday we'll debug this, get it working. And then Tuesday what I'll do is I want to try some test cases in terms of how we expose debug variables, because I have a feeling there's some different things we want to do there, and they will inform the last change to the structural elements of it. And then I think we'll be in good shape to say, like, okay, this is right now. All right, so I'll go to the Q&A. Am I able to do that? Awesome. Sweet. Yeah. If you have any questions about where we're at so far, go ahead and put Q: in front of them, and I will try to answer those questions. This Isaac, does it work? Well, no, it definitely doesn't work, right? So this is going to return 0, and this will get used, right? So until we implement that, it's definitely not going to work. Now, if you want to just kind of see, like, okay, what happens if we do something here, you could try to make one of these. If you want to debug it without implementing this thing, right, you can do that. You know. But I assume, like I said, there's going to be more problems. Okay, so first off, I don't really want to do all this because, like, I want to debug this on Monday's stream. I was correct in that we didn't close the final variable group, right? And do you see how that caught that? Because remember, I was like, the root group gets open and then the debugging group gets open. That's 2 opens, but then we only do 1 close at the end, right? And so I just wanted to... I knew that was not happening, and I wanted it to stop happening. Now, like I said, it doesn't actually matter because, you know, there's actually nothing happens when you close a group in our system. So you can leave as many of them dangling as you want, but I just feel like hygienically it's good to know that in case you accidentally left one of these other ones open, it would warn you at compile time. And I mean, again, I don't have a concrete reason for why. There's really no real reason. I just, you know, programmer meticulousness, I guess. Something like that. I'm not sure. So yeah. So anyway, putting that in will make it not crash. But yeah, like I said, we got to debug the iteration and the adding and stuff. So we just we're not really at a point yet where like I want to do that Monday and see what's going on, because I don't, you know, we wrote a ton of code there and we haven't looked at it at all. Diaboik17, earlier in the stream you said you once spent 10 weeks on a problem. What was that problem? Oh, I've spent more than 10 weeks on a single problem. I don't know if I spent 10 weeks on the witness's collision detector, but I probably did. I'd have to like add it up, because I did a lot of different things on the witness, and like only some of it was the collision detector, so I don't know if it was 10 weeks, but it could easily have been 10 weeks. And I strongly suspect that it was more than 10 weeks on just the collision detector. I spent more than 10 weeks on Granny's curve solver. Because, I mean, that was a totally new thing in those days, right? Like, nobody had really been doing any of that. And in fact, the source material I had to draw on from the literature, nobody was doing that thing. I had to draw on the people who had been doing curve solving for 2D shapes and use that for like sort of the basis of how to start thinking about it for animation. So that first curve solver took a while. I've spent 10 weeks on, yeah, I mean, I've spent 10 weeks on tons of problems, is I guess the way I would say it. Insofar as, have you considered using intrusive linked lists like those in the Linux kernel that use offset of? So I almost always use intrusive linked lists if you can. But you'll note, in this case, we can't. Because in this case, we have things appear in more than one list. That's why I had to do this, right? If things didn't have to appear in more than one list, we'd be back to where we started, right? That's the way we had it. That was an intrusive linked list, right? But in this case, they have to be external because we have things that are going to show up in more than one list. And that's when you can no longer use an intrusive linked list. Now we have an intrusive linked list, right? Which is the tree. So we do have one that's an intrusive linked list, right? I just want food. How portable will the game engine be? Could it be used to make other games? Well, portability-wise, it'll be very portable in the sense that we're going to make sure it runs on multiple platforms. In fact, it already is. Like, people have already ported it to SDL and stuff like that. But in terms of whether you can use to make other games, I mean, I guess what I'd say is I don't care. Meaning, it's not designed to be an engine that supports lots of games. It's just designed to be one game. So I don't know. I neither know nor care whether it would be usable in that sense, because that's outside sort of the goal of the project, if that makes sense. Cuber Caleb, curve solver. A curve solver is something, well, I mean, it's just a term that I use. It's curve fitting, really. It's like a solver that takes a bunch of data that is not curves and turns them into curves, right? So like it takes a bunch of points and runs a curve through them or something like that, right? Insofar as, will we ever see the memory chunk debug visualization? Yeah, we'll do that eventually for sure. I don't really know how we will visualize it. I can't promise the visualization will be very good because memory is kind of hard to visualize, unfortunately, since there's lots of little things that, so, I mean, it might just be like a line with little chunks on it, but, you know, we'll do that. So looks like we're done. Alrighty, let's close it down. And IMAP US Hover, currently it's on Mint. Because I don't have time to install a new thing, so I just don't put it to sleep. It's been running continuously since the last time we streamed. And so, unfortunately, yeah, I will try to make another installation sometime soon. But yeah. Insofar as, by the way, like, I mean, I'm not familiar with the Linux kernel implementation, but intrusive linked lists cannot have items in more than one list at the same time. Full stop. You can have more than one threading through that link. Like you can have, meaning, right? So you can have a thing that's like, you know, here's my element, and here's next and prev. If this is what you're talking in terms of intrusive linked lists, right, that can only be on one list at a time, period. However, you can always add another one, right? So if you added another set of variables, then you can have it on two different types of list, but not on two of the same type of list. So whatever this list was, if this is like, you know, the foo list, it can only ever be on one foo list. But there can be a bar list that uses a different set of variables, and it could be on two of those, right? But once you fix this offset, whatever that is, you can only ever be on one of that kind of list, whatever that kind was, right? And that has nothing to do with your implementation. That's just fact. That's just like category theory or whatever, right? That's just the end of the story. Can you give me a quick rundown again of how you're substituting the stack for instances of the debug view? How you're substituting the stack for instances of the debug view. Can you ask that question on Monday? Because I don't think I understand it, to be honest. And Martin Cohen, so what do you use as a formatting language usually? I typically don't do those sorts of things. Just not something I normally do. Yeah, I mean, usually I mark up things semantically. So I might like have markup in things that says, oh, this piece is like a, a proper noun. You should, map it that way or look up a link for it or something like that. I'll do stuff like that. But I rarely, if ever, I just haven't written programs that want to say like, make this next piece italic. And it's not, I don't, I'm not disparaging that or anything. That's a totally fine thing to do. I just don't, I just don't have occasion for it. I have not had occasion for it. Cuba Caleb, is this how you do UI in your other programs? So, yeah, I mean, some of it is, some of it isn't. Like I said, I'm kind of working out a specific way of doing UI. I want to show how you arrive at a good UI structure. So I'm doing something that's intentionally slightly different than, the exact way I may have done it before. I usually try to do that even when I'm doing it myself, so I can see if maybe there's some productive new things that I'll learn or arrive at by trying something different than what I've already done. All right, I'm gonna call it done. By the way, thank you to everyone for helping me the other day get my hex chat to show the list of people. It's pretty nice now to have it say like 159 or whatever instead of 0, which is what it was saying all the time before. It's nice to be able to see everyone again, even if it is kind of just little list of names. It's nice to see that there's other people instead of the weird thing where Twitch was not telling me anyone was here. So that's cool. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, you can always pre-order the game on handmadehero.org. It comes with a source code, and you can play around with it yourself and experiment with it and learn from it and do, other sorts of fun things. We also have a Patreon page if you want to support the video series. It's always much appreciated. We also have a forum site where you can go to ask questions or view an annotated episode guide. And finally, we have a tweet bot. The tweet bot will tweet the schedule at you. And it will tell you when the live stream is going to happen. Speaking of when the live stream is going to happen, not tomorrow. I will not be around during the stream time tomorrow, so I cannot stream, but we'll be back on Monday. So check the tweet bot for that schedule. I'll try to update it this weekend. Thanks everyone for joining me, and I will see you guys on the internet. Till then, have fun programming.